Hi guys, I hope you're good since last video. So in this video, we're gonna be checking on the ownership and borrowing concepts of Rust. We're gonna do that through learning. So learning how to do a for loop in Rust. So there'll be a part in which we're gonna be explaining how to make for loop. We're gonna compare it to Python for loops, so that we can have a reference and at the same time enter into the concepts that are different from Python, which are the ownership and the borrowing rules in Rust. After that, we are going to use a for loop. A for loop, we're going to use the concept of private and public functions. So we're going to use a private function inside the public function. The public function is going to be looping over some values, and we're going to use it as a module. That module is going to be used by the main.rs, which is going to be printing the result. So I promise you that we're going to have compiling errors, so you'll be able to see compiling errors, coding errors that you can encounter as I'm doing my own errors and keep them on record. So let's get started. Looping constructs in Python versus Rust. So we're going to check the loops between just check the comparison between Rust and Python. So in Python we have the for loop, the while loop. In Rust we have the same, the for loop and the while loop, but we have a third one, which is a loop keyword that you use. So that's the third way that we're going to see later on, how to manage that one. Iterating over collections. So the Python example is a list of numbers for number in numbers. In Rust, we have the same, but we're using a vector. So vect put those numbers, and we are going to loop over almost the same way. So the memory implication in Rust, when you iterate over a collection using for num in nums in numbers, you are moving the ownership of each element out of the collection numbers unless you're iterating over references. So we're going to see this in the details here, where you have owners of variables. I mean, you have one owner of a variable, and this ownership can be moved. And when this ownership is moved, that variable, which was the initial owner, you can't use it anymore. Or you can just borrow that ownership. So that means you can borrow and use that variable using another variable. And the initial variable is still available for other variables to borrow it or to transfer the ownership to another variable. But we are going to see this into the details. That's we're checking the loops. At the same time, we're going to talk about the ownership and the borrowing concept in Rust. So borrowing in Rust loop, to prevent moving ownership and potentially invalidating numbers here, you can iterate over references. So you use for number in, after you put the ampersand and the sign, so you put it with number just in front of it, and this means whenever you see that sign, that means it's borrowing all those numbers, all those variables which are in the list, in the vector. So ampersand numbers borrows a reference to each element. Memory implication, no ownership transfer occurs. So the initial variable numbers is still owner of those values. the data is not moved. So avoiding unnecessary memory allocations on the allocation. So there's less stuff happening in the memory, so it's advised to just borrow. So range-based loop. For I in range 5, we print I in Python. In Rust, we do almost the same, but we use in 0, we use double dot 5, while here 5 is not included. So 0 double dot 5 creates a range from 0 up to 2, but not including 5. So memory implication, ranges are efficient and stacked allocated. They don't require a heap memory allocation. After the memory is composed with the stack and the heap, so in the heap will be the, let's say, stretchable, modified, the variables that can be modified, can change size. So it's in the heap to have this ability to change the size, while in the stack it's more, let's say the size is fixed. Or the references can be also in the stack, or the string, for example. So the references to the heap bytes can be in the stack. Enumerate iteration. So in Python, for index value in enumerate iterable, we print the index and the value. In Rust, for index value between parentheses in iterable dot, we use the iter function dot enumerate function, and after we can access those variables using the formatting of the macro println. So here that iter is just a function that returns an iterator over references. So here we're borrowing. That's what we're doing here. So memory implication, efficient iteration without moving the data. So without moving the data means that we don't take the ownership, we're just borrowing those references, we're using those, and we can print those references that have been borrowed. We can print the values. Consuming versus borrowing iterators. So just to go into the more precise thing and details of it, consuming iterators, the definition, iterators that take ownership of the elements they iterate over. Here, let nums is a vector we use for num in nums. So nums here is no longer valid because we're consuming it. We're consuming the values of nums, while in the next one we will be borrowing. So here, the first example, the memory implication, ownership of elements is moved. The original collection can be used after the loop, while in the second here example, borrowing iterators, the definition, iterators that borrow references to the elements. The example, let nums, we use the vector, same as in the one above example. So for num in ampersand nums, so the sign that you put just before nums, the sign, this means that you're borrowing. So here nums, the vector, can still be used. So you can reuse it, you can use other variable to borrow those values. You can do whatever you want with it, it's still available. Memory implication, elements are not moved. So nums is still the owner. They remain in the original collection. Iterator, adaptators, and closures. So Rust provides powerful iterators, adaptators that allow for functional style looping. So here we have in Python the list comparison to iterate over the range. We have almost the same in Rust, but it looks like also like a lambda function also in Python. So let squares, we use here the colon to say to just say which type of values. We just define the type as a vector with I32, so with integers that can be positive and negative. 32 is the length of how long can be the number. After equal 0 to 5, so that's the range that we've seen before. And here we use a map function, which is already available. And the map function is going to use, it's going to do the same as in Python. It's going to return x, x multiplied by x for each x values between 0 and 5 not included. And the dot collect at the end, as the map function is going to be borrowing. So those values, collect is going to be, let's say, changing those and putting those into the vector. That's how it becomes a vector. So memory implication, iterators in Rust are lazy. They don't allocate memory until collect is called. So the variable squares, the vector, is created only when the dot collect is called. Efficiency, Rust's iterators can be as efficient as manual loops due to zero-cost abstractions. So the while let loops allows looping while a pattern matches. Example in Rust. There's no example in Python for that because it's Rust. Let's let mute iterator. So here mute, we use the keyword to say that we can transform this variable into a mutable variable. As all variable in Rust, as we've seen in the previous video, they're all immutable by default. After we got an example here with some iterator, and after we use the while let some value equal iterator, and we use the next function, and the next is going to be passing over through each values. So here the memory implication efficiently processes elements without extra memory allocation. So this way of doing, for the moment I don't like it because I'm coming from Python, and I prefer to use the looping ways, which are looking more like a Python way, so that I can learn a bit quicker. But I see here it says while let some values. I know that in options is using this sum function also. So it depends. If you feel comfortable of looping over the values like that, you can do it. But I would use just a normal loop and make the variable mutable using the mut keyword. Infinite loops. So I have to be careful, you have to exit, because this one here, infinite loop with loop, useful when the exit condition isn't at the start. So that's what we've seen is the third way of doing loops in Rust. Told you that we're gonna see it later, and that's the time now. So loop, and you see here there's a break after the condition in the loop. So if you don't break, what's gonna happen? Your compiler is not going to say anything. Everything is going to be fine with your compiler, and the code is going to be running until it crashes your application because of some memory issues. So here the memory implication care must be taken to prevent memory leaks or stack overflows by ensuring the loop exists appropriately. So this one I use it separately, is just to talk again about ownership, memory safety and ownership. that will be the last explanation here. Rust's ownership model. Ownership, each value in Rust has a single owner. That's the rules that you need to know. Borrowing. References allow you to access data without taking ownership. So you can have also one owner and several other values borrowing from the same owner. But at this time, there will be the lifetimes, which are going to be engaged depending on the scope and how long those values are available. So the lifetimes ensure that references are valid as long as they are used. So be mindful of ownership when iterating in Rust. Use borrowing and or end mute. I'm going to call it end ampersand or ampersand mute to avoid moving data unless necessary. Leverage Rust's powerful iterator adaptators for functional style looping. So, implication in loop. Moving ownership or item in collection. So here the collection variable we're iterating over. So collection is invalid. We can't use it anymore because we're consuming it, removing the ownership. So in the second one, borrowing the data for item in the end collection. Item is a reference, so collection is still valid here. Mutable borrowing for item in end mute collection. Item is a mutable reference. And after here, we use a start item plus equal 1. And we use the semicolon. So here, just to explain very quickly about the start. So here what's happened is that we are getting the variables from a mutable reference. We need to use a start on item. Why? Because we need to access to those values. So what's the difference between the borrowing one just above for item in hamstring collection? Is that here we show in this example that we're using item to make an operation. So here we're adding 1 to item. So we're using hamstring. So we're using end, means that we're using reference of the value. Therefore, we need to use a start here. Start in Rust is to have access to the value behind the reference. So behind the reference of the value, we get the real value and we add 1 to it. At this time, you can make operations. So the star, you're going to see it. And I believe it's good to see this example now. We'll be talking about ownership and borrowing, so that you're not confused if you see it in the future. You just tell to yourself, I'm doing an operation here, so I'm manipulating this variable. I say this mutable, it's okay, so I can manipulate it, I can change it, but I have to be careful. It's a reference, so it's something that I've borrowed because I used the end, I used the hamstring, I mean the ampersand, and I need to use the start. If I don't use the start before item, I won't be able to access the real value, and I won't be able to do the operation. So at this time the compiler will have an error if you don't use the start, and I believe the Rust compiler is very good. It's going to tell you where you need to put the start. So memory implication, understanding ownership and borrowing is crucial to prevent data races and ensure memory safety without a garbage collector. So in Python, you don't need to think about all of those stuff implicating the memory, as there is a garbage collector checking those rules and doing the job on the behind the scene. That's why it's good. But at one moment you need to go a little bit under that level and try to understand what's going on. And I believe Rust is a good language to learn in order to be introduced to those lower level concepts and be able to manipulate it as is it's more modern, it's more closer to how we use code at the moment. Private and public. So we've seen here the concept of public last time. So from a model, we use the pub keyword. So the pub keyword may also be used in a declaration to re-export an identifier namespace. But we used it just to make our functions available. So that's what we had last time in our main.rs. So what we're going to do, we're going to create a new file that we're going to use and export as a module or import. So fibo.rs, we're going to create a function. So fn to create the function, we're going to call it Fibonacci. We're going to take an n number, which is an unsigned number, U64, and return a U64 number. Means that the numbers can be only positive numbers. So if n equal to 0, we're going to return 0. So we get rid of the two first conditions in order to start outputting the result. So when we enter in the if statement, we don't need the semicolons at the end, because we are in that little scope and we're going to be returning that. After, if we enter in the else if n equal to 1, we're going to be returning 1. So that's the two first numbers of the sequence. Else or any other number. So the compiler is going to give us an error if you use a negative number, because we say it has to be a U64, so positive numbers only. So here we're gonna go recursively from here. We're gonna just add up the number, the n-1 numbers and the n-2. So Fibonacci, we call this function again. So inside the same function, we use n-1. So if you have 5, for example, it's going to be 5 minus 1, it's going to be 4, plus 5 minus 2, plus 3, it's going to be 7. Okay, so here we use a semicolon. Or not, we don't need. So semicolon, not semicolon, semicolon, not semicolon. We don't use semicolons, because each part is going to be returning the variable. So let's comment it here. Rust implicitly returns. Okay, that's why we're not using those semicolons. So what do we do with this function? This function is private function. So we're not going to use the pub keyword on this function. We're going to keep it as default private. So in Rust, everything by default is private. And here we're going to use a public function. So we're not exposing the Fibonacci function. we're going to be just exposing the wrapper. I'm going to make a function here calling the pub keyword to make it public, so accessible from another file. We're going to call this one fn range fiber. So I don't know what are the conventions in the namings, if you use camel case or underscores, but I'm using underscores. So range fiber have a value, and we're going to use this value, which is a positive value, a U64. And it's going to return so let's call it loops directly, and talk about those loops, what we've seen before. We're going to use it now. We go to U64. We're going to be looping over that U64 using a for loop. There's different ways to loop over variables in Rust, but as I told you, I'm going to use what is closest to the Python way, and that's the way I learn the best and the quickest. And after that, if there are some particular different ways to do, I can explore later on. So for num in 0 double dot val, so that means here val is not included. Println, we use the println macro. Exclamation mark. Exclamation mark shows that it's a macro. And we're going to be formatting here an answer. So let's call it fiber of, put here something is equal to something else. Here we're going to use the num and the val, the num variables. So Fibonacci and 64, U64 we're going to call it. Put here the variable inside. So Fibonacci num. Okay, so do I need to put the semicolon? Not sure, but I don't need it, I think, but I'm going to put it as I'm still learning and I might forget it in some crucial parts. Documentation here and how to loop. Here it's using the loop, the third way, the Rust way of doing it. So you can go over the documentation and look for it. Rust provides the loop keyword to indicate an infinite loop. The break statement can be used to exit the loop at any time, whereas the continue statement can be used to skip the rest of the iteration. Okay, count +1. So that's another way to loop, as you've seen in the examples before. I'm messing up the documentation. Let's leave this page. Nested labels. Okay. Rust loop over range. So you can just search through the internet, find the book, the Rust book here, for and range. The for in construct can be used to iterate through an iterator. one of the easiest way to create an iterator is to use the range notation a.b to yield values from A inclusive to B exclusive. So B is not included. So you can see here what's the notation. You use equal if you want to keep it, if you want to have it included actually. Okay, so that was just a little parenthesis on the documentation. It's good to repeating so that learning like that. For loop, you can put a comment on this function. 0 inclusive and val exclusive. Exclusive. It's not included. It's excluded. I should have put. And what else to say? What we said before again, for loop with val as an inclusive number as well. You can use for name in double dot equal and we add val. So we need this equal to say that we're considering that last value to be also used. Okay, so let's close those comments. Range fibo, that's my function. Which is going to be a public function, as you can see here, pub. We're going to be using the private function in it. We're going to go to the main.ars. We're going to import the module. Okay. And we're going to create a new print statement. You can call here the function directly, but we committed to just use the println to be able to format it if there's any issues. So here we use same the module name, the dot notation in Rust is double colons, and the function name is range fibo, and we're going to be putting a value inside of it. Put the value of 15. Let's go to the compiler. Cargo run. We got an error. Let's analyze the message here. We can maybe check the files. So fibo. The name of the file is fibo, as you can see. But I'm using range fibo. I'm using the function name. When you import a module, so you need to import the file name, not the function like that, which is fibo, and here also is just fibo, the file name. So formatting errors. So here we're going to see that after running this, it's not going to work again, even if you did the import correctly. Cannot be formatted with the default formatter. So there's a display, as you can see in the help is written, which need to be implemented because println can't format it this way, but we can use colon question mark for the for the macro println to be able to use the debug which is implemented to it in order to check how to print it. So it can be colon question mark. I've used only colon question mark, but I've seen the documentation that there's also dash question mark. So when print is not implemented and can't be formatted. Okay, and now when we run it, it works, but we don't get the right results. So we did a mistake somewhere. 610 everywhere, what it shouldn't be. So it's good to see those errors. We got the sequence here, 0 to 14, 15 is not included, but we need to fix this error. Okay, so important to do the right module import. File, which is the file name, not the function. The second one, it's some print are not going to work because they don't have the display implemented. So how to display the output. So we can use colon question mark. And here we can check our function. What's the error? What did we do wrong? We have pub. We're looping over the numbers from 0 to val. After reprinting, formatting equal to num. So we got the num, right? But what we don't get is Fibonacci val. So that one is not right. That's normal. Because as you can see, we use here Fibonacci val, which shouldn't be. It should be Fibonacci num. That's the number that we want in. So we're looping over those numbers. Okay, I go run. Here we get the right results. Okay, 0, 1, 1, 2. Is it the right results? Tell me in the comment section if it is right. Not sure. And here val was the error. Instead of num, I put val. So that's just a dump error. Just normal beginner error. What we can do, we can maybe make the output. See here the output, we get the module. In the file, we used the formatting using the debug implementation of a println macro, so that the range fibo can display the results. And in this one here, we're using this private function inside the public function, using the pub keywords, and after we do our for loop over those values. So here we're taking the ownership of it, because we don't use the ampersand. And you get this at the end because we don't return anything. So we're just printing, so you're gonna get that when the function is not returning. Okay. And just to show you that if I get rid of the semicolon, is the same, we get the result. So this validates what we've said, that the last value returned doesn't need the semicolon. You will see me putting semicolons because I'm worried to forget it in some other crucial parts. So That's it. And we might also comment out what we've done before. So do you remember how to comment? Multi-line comments. You use a dash start. After you enclose the lines that you want to comment out, which are those ones here, and we comment those. So you can get a warning. You see I've run it, but here it says even number is never used. So it's good to comment out or put, so the compiler were telling us to put a kind of a decorator above it to say that we can avoid using it. So here it's fine. I'm just going to use this comment. Here we get our output. So we've seen a lot today. Just check the first part of the video and understand the ownership and the borrowing rules, which are the hardest stuff to understand for us coming from Python. Hope that you like this video. We're going to keep discovering Rust, different concepts. I hope that you like this format. That's what I'm going to use in the future videos, I believe. I'll put the console in the middle because I might make some shorts using using the videos that I've already made. Alright, please like and subscribe, and see you next time.